We're going to have a look at differential calculus. And calculus in math is the study of change. And we encounter this, this concept here of rate of change. We've seen this before with the gradient of a line, how quickly it rises or how quickly it drops. If we have a curve like this, we can mark 2 points, A and B, and we can draw a straight line between them, like this. Now, a straight line cutting across a curve like this, but not going across it, just going between 2 points on the curve, is what we call a chord. So this is a chord. Whereas if you draw it through the curve like this, this is what we call a secant. So that's the difference between a chord and a secant. So we've drawn a chord here from A to B, and we could find the gradient for this straight line, and we know how to do this. We have 2 points here. We have A, which is the point 3 and 2, so 3 on the x-axis and 2 on the y-axis. So this is the point A, and we have the point B. Now the change from A to B is a change in x value and a change in y value. And we can express this change as the gradient of the line AB. And we find the gradient by linking the change in y value with the change in x value, like this. So you might remember this from before. So this actually means change in y value, and this is change in x value. So this triangle is called a delta. It's a Greek letter delta. So D for difference, right? So the difference in y and the difference in x. So this gradient then, and this is previously we've called this m. So the gradient m gives us the average rate of change traveling from A to B. So the gradient for the chord AB is going to be y2 minus y1. So y2 is going to be the y coordinate for B, and y1 is the y coordinate for A, divided by the difference in x value. And difference is the same as subtraction. So the difference in y value is going to be 12 minus 2. The difference in x value is 9 minus 3. And now we're just looking at the y value in the coordinate. So 12 minus 2, 9 minus 3. And that gives us the gradient. So this is going to be 10 divided by 6, which is approximately 1.67. We'll note this general rule here. The average rate of change between 2 points is the same as the gradient of the secant through the 2 points, or the chord between the 2 points. So that would be the same thing. But this is basically, it's a straight line between 2 points. If we find the gradient of that, we find the average rate of change between the points, right? Now, we are familiar with gradients of straight lines. In Norwegian, we call this stigningstall. It tells us the rate of change. Right? Now, what is the rate of change in a single point? That is going to be our next our next point. So the rate of change in a single point. Now this may seem like a strange question. What is the rate of change in a single point? But we can observe that at different places on this curve, you have different degrees of steepness, and we've seen with the Stigningstal, a gradient, that for a straight line, the rate of change is constant. It's not constant for a curve, so it changes. So you would expect a gradient to be higher up here than it is down here. So the rate of change can actually change too. So we're going to imagine what is going to happen when we edge closer to A. And we could draw a secant from a point C up here with coordinates 8 and 9. So we have a straight line going from A to C. Now, the gradient of this line would be, again, the difference in y coordinate divided by the difference in x coordinate. And here we have 9 minus 2, and then 8 minus 3, which is 7 divided by 5, which is 1.4. We could also imagine a chord going from D to A. And okay, so this was a C and a D. We could imagine a chord with the gradient, again, delta y divided by delta x equals 7 minus 2 divided by 7 minus 3. That's going to be 5 divided by 4, which is 1.25. We could do the same from a point E. Okay, so I'll just try a different color for that. So a E, that chord has a gradient that we can find in the same way. And the coordinates for E is 5 and 4, so we have 4 minus 2, and we have 5 minus 3. 2 divided by 2 is 1. Yeah, and so the gradient of that chord is going to be 1. Now, we could also imagine that we move closer from the other side. And we could find the gradient for a chord going from this point F with coordinates 1, 1 to A. So FA, this chord has a gradient of, let's see, this is going to be 2 minus 1 divided by 3 minus 1, which is 1/2, or 0.5. So we would imagine that the gradient in the point A should be between these two numbers, between 1 and 0.5. Now we could draw points that moved closer and closer to A, and we could imagine a line going through 2 points on either side of A, both infinitely close to A, and this line would be a second going through 2 points very, 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 very close to A. And this happens to be Joseph Leibniz's definition of what we call a tangent. So a tangent is a straight line that touches the curve in a single point. So a tangent is a line that touches the curve in a single point. And now the main concept, the most important concept of differential calculus is instantaneous rate of change. So this means the rate of change in a single point. So the instantaneous rate of change at a point is the gradient of the tangent at that point. And in the next video, you're going to learn a formula for finding what we call the gradient function.